Good afternoon, everyone. I want to welcome you to today's special topic webinar on spray foam installation and termite inspections. Before we get started, we're going to go over a few housekeeping rules. Everyone, please mute your line. If you have any questions, please place them in the chat and we'll answer them at the end of the webinar. If you have a question that you forget to ask, you can email it to us at education@nola.gov and we'll answer it that way. And this webinar is being recorded and will be uploaded to our YouTube channel. Today's speaker is Ed Freytag. Ed Freytag graduated in 1986 with a master's degree in entomology from the University of Wyoming. After working 1 year as a research associate in the entomology department at the Louisiana State University, researching bark beetle control, he joined the New Orleans Mosquito Control Board in 1987. From 1993 to 1996, he worked in a private toxicology laboratory in Matawan, Michigan, conducting inhalation toxicology research with rats, mice, and primates. In early 1996, he resumed the field operations supervisor position with the New Orleans Mosquito and Termite Control Board, conducting termite field trials with liquid termiticides and bait stations. He is currently a research entomologist and assists with termite research operations with chemical manufacturers, universities, and federal agencies to test the efficacy of proprietary chemicals for the control of Formosan, native subterranean, and drywood termites. He is also involved in the testing and use of innovative technologies for the detection of termites in structures and trees. Ed Freytag is also an award-winning photographer and specializes in macro photography of insects. And now Ed Freytag.
Thank you. Appreciate the introduction. So just get a little history on this. So I've been given this talk several times, but has never been recorded. So a gentleman by the name of Timothy Patterson of Maxwell Pest Control in Mississippi, he wanted to get some information on spray foam. And he said, is there anything that you have that I could use? I said, well, I do have a presentation, but I don't think we recorded it. So that's what we're doing this one again. So we can record it, we can make it available for everybody. So thank you for joining us today. So give an outline. So I'm going to talk about insulation, EIFS, which is exterior insulation and finish system, a little bit of history on that, how it came about, what it's about. Spray foam insulation, which goes on the inside while the EIFS goes on the outside. And again, some history on that and why it's used and what are the advantages and disadvantages. Now that we understand that, I'll talk about what is a termite inspection, at least how I conduct them and how most everybody, goes around conducting inspections. What kind of things we're looking for, such as conducive conditions and problems. A little bit on termite identification, just to remind everybody what the termites we have here, what they are, what they do. Work on down to inspection tools. And then I got some case studies that I think you'll all be interested in looking at. And then we'll have some discussion, maybe some question and answer towards the end. So based on that, so why do we use this EIFS or the exterior insulating system and spray foam? Well, the biggest thing is you get such a savings on energy bills, both in summer and winter. They have such a much higher insulating value compared to other materials like fiberglass or cellulose. You can see there on my graphic is that it's almost double what the other insulations have. So that's a really big, advantage. And that's why we see so many homes with insulation now. Let's talk about EIFS then. EIFS, it stands for Exterior Insulation or Insulating and Finish Systems. So it is an insulating and decorative and protective finish system for the exterior walls. And it can be installed in any type of construction. It's very similar to stucco. As a matter of fact, sometimes it's really difficult to tell whether it's real stucco, which is made out of cementitious materials. But the components are really different, and the installation requirements are also very different. So I'm going to go over some of those things. The nice thing about this EIFS is that it has a great selection of shapes, colors, and textures that can replicate almost any architectural style or finish material, or stand by itself as an architectural finish. I'll have some pictures of that to show you what I'm talking about. So a lot of the commercial applications go with this EIFS, and you can see that this particular building, I guess, is a church. It would have been very difficult to construct using current materials such as concrete and stucco, regular stucco. The homeowner application, it's also very, it gives you really, really neat looking architectural designs because basically you're working with foam. So a lot of homeowners like it because of that. They like the fact that they can have a much higher R value, which is the insulating value, and that makes it very attractive. Now, back in the days when they first came out with this, the EIFS was designed so that the foam was either attached to the substrate, which is either plywood or OSB. It was applied directly or glued directly to your substrate. And then you had the foam, and on top of that, there was a reinforcing mesh and a finish and a base coat and a finish coat, which made it very, very stiff, very, very hard, and waterproof. And that's where then you apply the paint to that. This is a cutout from a house in Biloxi, a very big house that had issues with EIFS. And you can see that this was the old system where the foam was attached directly to the plywood, and on top of the foam you can see the other base layers, which are the base coat, and then a mesh, and then this fiberglass and paint. So I'll talk about some issues with this system, the old system, that when they first came out with it, and why they had to improve history. That so back in Europe, 1952, the patent was granted for expanded polystyrene (EPS) insulation board, and then in 1969 here in Rhode Island, um, uh, Rhode Island-based Drive-It Systems introduced EIFS, and it was used in a wood frame house in the USA. That was the first time it was used. So it became very popular during the oil crises of early to mid 1970s. If you can recall that, it's kind of like we don't have an oil crisis right now. We just have very high oil prices. But back then they were just really, everybody had to make big lines to get gasoline, and it was, very difficult. So a lot of these systems became very attractive in order to save energy. I mean, energy was basically, the bills were halved when you use these systems. So EIFS was almost used exclusively in commercial buildings until the 1980s, when it gradually became adopted to use in homes. But unfortunately, from 1980 to 2000, there was a lot of EIFS failures. There was a lot, especially in the northern states, Canada. And the problem is that because of that design, once you got moisture in there and got into the OSB or into the plywood, that moisture didn't leave. You ended up with a lot of rot, a lot of fungal rot. And there was a lot of lawsuits. There was a lot of problems with it. And so they had to remediate that. So what they came up with, and it just happens to be one company, what they came up with is a something like a preventative substrate that was waterproof, and also a barrier that allowed that moisture to drip down. That's what it didn't have before. The rest of it is pretty much the same. You still have the expanded polystyrene boards, which is expanded foam. You had the reinforced mesh, the finish, the base coat. Everything else was the same. The biggest difference is having a waterproof backdrop with a way to move that water down and out of the wall. So why are we still having problems then? Well, back then there was no weather barrier placed over the sheeting before the exterior cladding. So the polystyrene boards were glued directly to the sheeting. If water got in there, the sheeting would get wet. The other thing is that the applicator training or oversight was not there. There was no real training. So basically what they said is that if you couldn't stick to the specifications because it took too long, then I guess the installers and construction costs were, they figure out a way to make it go quicker and save costs. So maybe they didn't install it properly. So there's also deviations from installation guidelines. So you can't have that foam insulation below grade. That means it's into the ground because it's going to basically suck up moisture. You have to have the windows and doors properly flashed, and the roof. All these flash has to be done properly. And in some cases, maybe they didn't put the flashing, which is a metal piece that allows that water to drip out. Another problem that I found is that there are divided responsibilities. So the contractor and the EIFS applicator are two separate entities, so they don't always agree on how to do things. So maybe it wasn't the plan wasn't followed properly, so the installation maybe wasn't done right. Now, another failure was that it becomes a closed envelope. So because you're putting all this foam around the building, the interior of the house and the exterior of the house, the pressures are different. So if you have a crack or if you have a leak, basically when it rains, it sucks that moisture into the wall, to the exterior wall. I mean, material doesn't breathe. The other thing too is that it's not as like stucco where you put it on and, you know, unless it cracks, you don't have to worry about it. Well, in reality, when you put EIFS, you need to have annual inspections to make sure the sealant around the windows hasn't cracked or it hasn't dried up, and that you don't have, you know, water coming in and getting mildew or mold. So leaks or cracks have to be properly sealed, and sometimes homeowners do modifications, additions, or renovations, and they don't get inspected by a qualified EIFS inspector, so therefore you end up having water leaks. Now that we know a lot about EIFS, the exterior foam insulation, we'll talk about spray foam insulation because these sometimes are used in the same construction, the same building. So if you've ever been in an attic that has spray foam insulation, you'll find out that it's actually very comfortable. The R value is so high that even in the middle of the summer, it's actually very comfortable inside one of these attics. And you can see why. They got probably 3 or 4, maybe even 6 inches of foam, and that prevents that heat from transferring. So I'll talk about a little history on that. So the Army used it in its airplanes since the 1940s. There's 2 types of this foam insulation, spray foam insulation. So open cell foam insulation, and as the word says, well, the little bubbles that form when it expands aren't closed. So it's a lot lighter. It's using less chemicals, so it's less expensive to put on the walls. It makes a good air barrier, but not a water vapor barrier because again, so the little bubbles are open. And it's typically used on the interior walls, and it weighs about half a pound per cubic foot. On the other hand, closed cell foam insulation is denser, has smaller, more compact cell structure, and the little bubbles are actually closed. So it makes a good air barrier and good water vapor barrier, and is used in roofing projects, outdoor applications, maybe under the crawl space. And it's a lot heavier. It's 2 pounds per cubic foot. So big difference in the density and then the weight. Also a big difference in the cost. So spring foam insulation equipment, once, I mean, the equipment is rather expensive, but once you have the equipment, you still have to train and learn how to use this because you're mixing 2 chemicals, and some of the issues is if the chemicals aren't mixed properly, that foam may be too reactive. It may expand too much or may not expand at all. It may not cure properly. It may not stick correctly. So there's a lot of things go on with this spray foam that without proper training, it may not get the right insulation cell quality. So here's a spray foam insulator putting open cell between the studs. Now, one of the things that just from this picture, you'll realize is once they spray that foam, everything becomes encapsulated by the foam. So in order to see, as you see that electric wire in there, in order to get to the wire, you are going to have to cut into the foam. In order to get to that, anything inside the wall, the only way to get to it is you have to remove it and cut it, because it's not like fiberglass where you can take that batting out and then staple it back in there again. And I want to show you this right now, because when you're doing termite inspections with any kind of instrument, you can't see anything. I mean, all you see is foam. Here's spray foam installation, the closed cell type. This was done under a building to prevent the heat and temperature differences between the air conditioner and the heat. And so they use the spray foam closed cell. And you can tell when it's closed cell because when you touch it and when you try to press on it, it's very stiff. It's very dense. So the spray foam insulation, obviously, the reason why we put it in buildings is because of the advantages of saving you money on energy bills. So in some cases, you can reduce the heating and the air conditioner's equipment size. So maybe instead of a 5-ton, you can get away with a 3-ton. So of course, a 3-ton is going to lose less energy than a 5-ton. It also reduces air drafts, noise, and increases the comfort. I've been in attics with Timmy Madere, who's another inspector, and we were out there, it didn't even sweat. We did the inspection. Impedes the entry of insects and pests, according to the brochure, but as you will see later on in this presentation, that is not exactly as intended. It doesn't exactly happen with certain insects. It minimizes the air infiltration that can generate condensation. So in other words, if you have warm, hot, humid air from the outside going inside the wall, and then it hits that cold air conditioned air, it's going to condense inside the wall. Well, if this seals everything, you're not going to have that penetration. It seals small cracks, insulates large areas such as walls and roofs, resists settling because of the general stability, and it may qualify for utility rebates, tax credits, or green certification. I guess that depends on state by state or from location. I'm not sure about that. Disadvantages, though, is that during the application, the material is actually, from what I've been reading, and again, I want to give you a little bit more information about myself. I am not an expert on building codes. I'm not an expert on foam insulation. I'm just going by what I've picked up all these years I've been working on it, and what I can find from the brochures from the companies and YouTube and everything else. But the chemicals can cause respiratory tract issues, irritation to the eyes, skin sensitization, cardiac arrhythmia from blow-on agents, blurry vision and vapors of amine, catalysts, and organic solvents. That's during the application. So it does require the use of PPE, and in some cases it requires air supply. So special mask with air supply. So during the application, the site must be ventilated and the heating and air conditioning shut down, and typically it must be vacated for 24 hours or more. Now, again, some of the disadvantages, and again, this is just during application, is of the materials. So if it's not cured properly, there can be some off-gassing. And also, if they cut the foam during installation, you're going to have some chemical dust, which, if not vacuumed properly, it could create a problem later on. So most of these spray foam installations, which is polystyrene, is part A and part B. So part A of the spray foam is typically formulated with MDI, or methylene diphenyl diisocyanate, big words. It is an allergen and sensitizing toxicant. So these diisocyanates in general are known to cause asthma, lung damage, and even fatal reactions, according to the EPA. That is when it's uncured, that is the chemicals. Part B contains amines, which act as a catalyst. Glycols is the blowing agent that makes it react into a foam, and phosphate is a flame retardant. Those are the components that go into that foam. Now, I did see a video where they actually showed the foam and all the other insulation materials, it caught them on fire, and that foam burns and burns and burns for a long time. It produces a lot of noxious gases. So just something to remember. So what about pests? I read this on brochure. It says in there that open cell and closed cell spray foams act as a physical and odor barrier that has shown to significantly reduce the number of pests entering structures. Well, it keeps dogs and cats out. I know that for a fact. It offers no food value, and while it by itself does not represent a concrete entry barrier, pests normally do not attempt to go through an area where they cannot detect a food source. That is normally correct, but rodents really like to penetrate and nest in it. It doesn't bother them to put holes in it. Termites, it really doesn't bother to go, they don't eat it, but they'll go right through it. And ants, especially some of the ants that are house invaders, like acrobat ants. I've had several buildings with acrobat ants actually were nesting in it, and there was just dust everywhere from them chewing on it. Back in 2013, this is from, let me see, CBC News. Even back then, they were saying that spray-on insulation can be a highway for termites. So, wow, I mean, back in there, we're already having issues with termites. And I want to show you that what NPMA has to say about that. This is a little video that I picked up.
I'm Dr. Jim Fredericks. I'm the Vice President of Technical and Regulatory Affairs with the National Pest Management Association. And one of the things that we're working on right now is spray foam insulation. It turns out that spray foam insulation, when applied in crawl spaces or basements in a way that covers up the sill plate or the band board, makes it extremely difficult for termite inspectors to detect termites. Either early detection or as part of a warranty inspection. That substructure is really one of the only places that a termite inspector can actually see the structural timbers. And when that's covered up, it's virtually impossible to know if termites are there. As a result, we have pest management professionals who have customers under warranty, sometimes long-term customers, and they need to void the warranty simply because the risk is too great if you're not able to detect the termites. So over the course of the past year and a half, we've been working with some of the spray foam industry associations, the groups that are representing both the applicators as well as the manufacturers, to educate not only the spray foam installers, but also pest management professionals about ways that the two could actually coincide, work together. And so this is a big project for us. This is something that we've been working on for a year and a half, and it's a challenge for everybody in the industry.
Okay, so now you heard from an expert from NPMA saying that there is a problem for the termite, industry. And I also found this on PCT Magazine 2019, in which the Spray Polyurethane Foam Alliance, SPFA, represents all foam installers, has asserted that newer technologies can help detect termites when spray foam is applied. Kurt Reisenberg, Executive Director, SPFA, said that termite professionals have not kept pace with technological advancements and instead continue to rely on old inspection techniques. Well, that's good and dandy, except that I've got pretty much all the tools that he's talking about and just don't work. And that's what I want to show you. So before I get to that, though, let's just review termite identification, because you have to know your termites in order to do the proper treatment. So here we have Barry Lyons sucking up some termites with an aspirator, and then looking at them, and sometimes we just bring them back to the lab and put them under microscope if we're not sure, especially if we just collect wings or just parts of the soldier, like the head. So here's termites, and you should be able to tell me what these are without having to actually go to the NPMA manual or some other guide. So looking at head capsules, you can tell that the one on the left is kind of blockish, is rectangular. The one on the right has a teardrop shape, and the one on the bottom, the workers look like little sausages. And not only that, but they have these little pellets, right? So these subterranean termites have a rectangular head. For most of them, subterranean termites have a teardrop shaped head, and the mandibles are slightly different too. And then drywood termites are the ones on the bottom. So one of the things that subterranean termites do is they make these shelter tubes or mud trails. And that's what we're looking for when we're doing a termite inspection. Well, and that's the only thing we're looking for, but we'd like to be able to see these termite trails, and you scrape the termite trail and you see live termites in there. Voila, you got, you found termites. The problem is when all this stuff is covered in foam, I'll show you some pictures of that, all of a sudden, there's just no way to see that or see the damage. Here's the damage in the basement or the floor of a house. And that was something that happened over a long time. But even with the infrared camera, I can see that. I can see there's some issue in there. Now, on the other hand, drywood termites, they aren't as easy to see. And part of the problem with that is they cut across the grain of the wood, and unless they drop these little pellets outside through their little pick-out holes, you're not going to know where they are. They don't build trails. They make small colonies. They might attack a door. They might attack the window. They might be on the flooring. Might be on the joist, on the studs, but you can't see them, and unless you get this little pile of pellets. And a lot of times what happens, especially if the homeowner has a cleaning service, they clean this up and you never get to see them. And then you end up having a problem with drywoods, which in order to treat drywoods properly, you have to do a fumigation. And I'm not going to talk much about fumigation and foam because that's a whole lot of thing. What they're saying is the foam may either prevent the fumigation to get into the timbers or may trap it inside the house. And even after you evacuate all the gassing, it may still stay in there. All right, so the three termites we're looking at is subterranean, or the two termites are subterraneans and drywoods. Now there's other pests involved, which are wood destroying insects, and you have beetles, lictids, and ostracids. But I'm not really getting into that because I'm just talking about termites right now, even though wood destroying organisms, fungal area, where you have fungal damage, that's another wood destroying organism. But when I'm doing a termite inspection, I'm going to look for live termites. That'd be the best if I can find them, because then I can collect them and put them on a microscope or just identify them on site. Sometimes all we find is termite parts, like on the picture on the bottom. Those are wings. So obviously, the more likely for most of termites. Termite trails. Maybe they're dry. That doesn't mean that they're not still in the building. That just means I didn't find any there. Termite damage. Conducive conditions, which I'm going to talk about. Moisture issues. And then construction issues, which is not a whole lot you can do when you're doing a termite inspection. So a conducive condition is any condition that makes the home or structure more likely for termite attack. And I'll give you some examples of that. So moisture and wood issues are the most common problems that I see. A lot of construction issues too, but again, not much you can do by construction issues. So how do these subterranean termites come in? Well, typically come from soil. They're always foraging for wood, or it's something that they consume. That's what all they eat is cellulose. So maybe they're in a tree 20, 30, maybe even 50 feet away or 50 yards away from your house. They find the concrete slab. They come in through the pipe penetrations or any kind of penetration. climb up into what, it doesn't necessarily have to be even a moisture issue. They can attack a home even if it doesn't have moisture, but maybe you have a bunch of wood next to it or some construction wood. They're going to find that. Eventually, you're going to enter the property, the structure. They think of a structure as a tree. They're just looking for wood. They don't care that it's got concrete around it. And that's why they attack homes. Otherwise, they won't do it. So some example of conducive conditions that I put together, most common ones: condensation from AC systems, especially on the pipes, on the ducts. Any kind of moisture, the termites will find it and they'll eat it. They'll take advantage of it. Water leaks of any kind, whether it's on the roof, on the windows, from pipes, leaky pipes, from leaky tubs, faucets, toilets, dishwasher. Any kind of water leak is a conducive condition and needs to be corrected. Planters or attached decks, they're right next to the house where you can't see the slab is a bad idea. Putting wood in the crawl space after construction or firewood next to the building, not a good idea. Leaking gutters and downspouts. Incorrect grade of soil from foundation, so the water, instead of running away from the foundation, is making a puddle and staying close to the foundation. Stucco, EIFS, and siding below grade. We're looking for these mud trails, and if you can't see them, how are you gonna determine if you have termites or not? Too much mulch or a mulch too close to the foundation. You should leave at least 12 inches between. The other thing is that if you put too much mulch, it may bridge the treatment, the soil treatment. Landscaping, putting a lot of landscaping around the perimeter of your house where you can't inspect. That's always an issue that I have, and after I'm done with inspection, I'm all scratched up because maybe they have holly. I have a word with a homeowner said, in order to do this properly, you need to have your landscaper or whoever works on your yard, if it's a homeowner, you got to cut down on all this stuff. It's just not good having it that close. And expansion joints and coal seams. So this is just an example of things that I find all the time. There's probably 1,000 different kinds of things that are conducive conditions. Here's one that looks really pretty, doesn't it? All the vegetation crawling up that wall. Well, it's not exactly, how you're going to see termites, even if you have a bait system. What if they maybe didn't find the bait system? They just got in the building through all this vegetation. How about leaky AC units, whether it's a window unit or the one up in the attic? Lots of times I find these pans. This one's rotted because it had all this vegetation that fell in it. But most of the time, what happens is the drain pipe gets clogged up with algae or whatever, and it overflows, and you end up with this conducive condition with moisture. So you got to have that checked periodically. Here's water damage in a roof. That has no termites at all. That is strictly up in a roof where they probably a branch puncture the shingles, and over time you see all those black material. That's all fungal decay, and eventually, if that continues, termites may find it. That's what they're looking for. They can sort of smell that moisture from a distance. I'd say smell, but they can detect it. All right, what kind of tools do you need if you're going to do an inspection then? Well, obviously coveralls. If you're going to be crawling or going up in the attic, a flashlight, a screwdriver, or something to poke around, a hammer, a ladder. There's really no excuse for an inspector going to a homeowner's house and saying, well, I can't go up in the attic or in the roof because I forgot my ladder. It's just inexcusable. Need a pencil, clipboard, and graph paper so you can, make a footprint of the structure and show where the conducive conditions are with the termites, measuring tape, collecting containers, and a camera. Everybody has a phone. You got a camera on your phone. Take lots of pictures. Homeowners love to see pictures, especially even if you don't see anything wrong. Taking pictures showing them, look, you got you're protecting your house really well. They like that. So just remember that it's not only the bad things that they want to see. They want to see that they're doing something good. That's me getting ready to crawl under a house. So just to give you an idea of what the equipment I have, I had a headlight, I got a face mask, and not for COVID. This is prior to COVID. That's because I don't like breathing whatever's underneath the house. It could be mouse feces, could be cat feces, urine, all kinds of stuff that are not good for you. I tend to have allergies anyway. I have a backpack with all my tools, containers, I got gloves, I got Tyvek suit on, I got knee pads, and I got nail-proof shoes. So if your inspector shows up in shorts and without protective equipment going in there, well, he may not do a very good inspection because he may not go all the way to every square inch underneath the house, which I tend to do. I tend to crawl in as far as I can. I don't want to miss a spot where the termites are. So how long does it take to do a termite inspection then? Well, it all depends. I mean, the size of the structure, the bigger the structure, the longer it takes. The type of structure, is it a ranch style, one floor or several floors? Type of insulation, if it's foam, it probably doesn't take that long because you can't see anything. But if it's regular insulation, it all depends. If you got insulation under in the joists under the flooring, well, that's going to take a little bit longer. If you do an interior inspection, amount of furniture and other items inside, pets, sometimes pets get in the way. I know I got bit by a dog one time. He was a friendly dog, but he was just trying to protect this house. You got to go in crawl space and you got to do the attics. There's really no excuse for not doing that. And then also the amount of damage or conducive conditions that you find. You got to check all of those. And landscaping. Landscaping tends to get in the way. And I spend a lot of time looking at trees in the homeowner's property because a lot of times they don't realize that the water oak is only 20, 30 feet away, even though they have a contract with a pest control company. The tree was not part of the contract and get treated. So especially if you have Formosan termites, they're going to keep trying to get into that property because, like I said, they're always foraging for food, even if they already have food. So when I first started seeing some of these spray foam buildings, it makes it really difficult. And it was like a head scratcher. Okay, where do I start here? Or do I just give up? Because I'm not going to be able to see, especially right here. And maybe that was a chimney. They sprayed all around the edge between the bricks and the joist. Maybe there was a trail coming from inside the chimney on that door. I don't know, but I can't see it. And unless you get permission from the homeowner, you can't just take a knife and a saw and start cutting everything down. So it does create a real problem. I mean, if you're just doing an inspection, maybe to put the house on a contract, that's the problem we're seeing now. I talked to a lot of pest control companies, and they said, I don't know, maybe I'll just walk away from this one. Now, why in the heck did this guy spray this corner? Was he just trying to get rid of the material? Because I have to break it on the bottom. There's no other way. I have to make sure there's no trail in that corner. Now here's Timmy doing an inspection. Notice he doesn't sweat in this attic because it was actually, they had air conditioning in the attic, which is nice and great, but we found termites in that foam. We just happened to see some mud. We're just going to tell how extensive the damage was. On the other hand, the house on the right probably was done by a lot cheaper job because they didn't put a whole lot of foam in there and they missed a lot of areas. So if they're going to do a job, might as well do it right. Don't do it, halfway there. But the one on the right was not air conditioned. The one on the left was air conditioned. And if it's not done right, what happens is they end up with mold everywhere because now if you have intrusion from warm, hot air going inside the attic, which is cold, dry air, it's going to stick to everything that's cold and it's going to mold over time. We've seen that over and over. Well, I don't just rely on my eyes and my experience. I do have to use other instruments. I use an infrared camera, moisture meter. an acoustic detection device. I don't have one anymore. It broke and it's not fixable, so I'm gonna have to get a new one. Flexible fiber optic borescopes to be able to see inside the walls. Microwave motion detectors, and decay detection devices, a resistograph. I have all of those except actually the microwave motion detector I don't have. But I use all of these in conjunction. It just helps me find moisture quicker, find damage quicker. But you have to know what you're doing. You have to be trained to get this, to use this instrument. So a lot of people don't use them because, well, they don't want to take the time to learn how to use them. These are the first, well, not the first. We lost a bunch of infrared cameras during Katrina, during the flood, but we bought these afterwards, and they worked pretty good. It was about $8,500 a piece. Bought 3 of them, but now you can buy this this FLIR One. It connects to your iPhone or it connects to your Android phone, and everything. I mean, you load the software, and everything you do it through the phone. We're looking at a wall here in the background, and you can see the studs, right? But how can you see the studs? That's, everybody thinks that infrared cameras are X-ray. Well, they're not. I'm gonna show you how they work. So basically, an infrared camera, it's reading energy, right? Heat in this case. So there's 3 types of energy. So reflected energy. So anything that bounces from, let's say the sun's hitting the wall and you feel that heat, that's reflected energy. You also have transmitted energy. So if you have a light bulb behind the wall, that heat or that energy is going to go through the sheetrock and the camera is going to read it. And then you have emitted energy. So that's the actual heat that's on the wall, but it's not reflecting and it's not transmitting it. So those are the 3 things. Now the camera itself, the infrared camera, it's only reading infrared. And it's not X-ray. It doesn't penetrate. It's reading the surface of the wall. Now, if you're going to use a thermal camera, there's a couple things you have to remember. One is you want to make sure that there's like a 10-degree difference between the inside of the house and the outside of the structure. Because if everything is the same temperature, if it's 70 degrees outside and it's 70 degrees inside, the studs are the same temperature as your sheetrock, as your wall. So you're not going to be able to see the studs. You're not going to be able to see any moisture. So by making this differential, you get really good contrast, and you can see the moisture of the studs. You can almost see it like it was an X-ray. Here's an example. This is up in a building, up in a roof. On the left, or actually on the right, you see what the camera sees, normal camera. This is regular light. On the left is what the infrared camera sees, which is 256 shades of gray. They don't really see in color. So the one you see on the bottom, that's been colorized. That's software. It just makes it easier to see, because a lot of times the shades of gray are very, very little and you just can't really discern it. Like on the thermal image, if you see some white lines on the right, those are the studs. It's barely visible. But when you change the color, sometimes you can really make those pop. Now in this particular image, you notice that's a square up there in that roof. And what we found out when we went up in the roof is that they didn't put any insulation in there. So you have to, the camera doesn't tell you what's termites. It just tells you temperatures. And you have to make sure that what you're seeing is what you think it is. In this case, turned out to be missing insulation. Here's a house that has the EIFS, the exterior insulating foam. And the one on the bottom on the right is what the camera, regular camera, sees. And then the one on top is your gray only, right? Notice it's very difficult to see if there's any moisture issues. So we put a color filter, yellow and green and blue, and it's a little bit better. But when we put the red filter, all of a sudden you can see that there's some issues with this house and turn out to be a lot of moisture. So the EIFS had very bad sealing around those windows and moisture was coming in. And he also had stucco below grade, which to this day hasn't done anything about it. And I think he's going to have some very bad issues, even though we gave him a report, told him what to do. Now, here is the problem when you're trying to see or trying to do an inspection using an infrared camera up on a roof that's been covered with spray foam insulation. On the picture on the top left, you can see where the rafters are because you see the bumps, right? On the picture on the right, that's what the infrared camera sees. It sees nothing. I mean, I can't make heads or tails out of there. On the bottom, this is over a door or a window, and you should be able to see the headers, and you can see, normally you can see the studs. Well, you can see the studs on the right. The problem is it's all these dark and light areas. I put my moisture meter and there was no moisture, although that really looks like it had moisture. The problem is when they put spray foam insulation, depending on the speed and how they do it, they get some areas that are denser than others. And, excuse me, and that gives you these different densities. And the infrared camera is, it'll pick up some of these differences in temperature because it picks up to maybe a hundredths of a degree. But I don't know if that's termites or if that's, I know it's not moisture because the moisture meter said it was only 10%. And that's not enough for the termites to be bringing moisture in there. So it makes that foam just makes it difficult to read. All right. I want to talk about some case studies, some things that I've been involved in. And also, I have a video that I picked up. And this is kind of a long side. It's 6 minutes, but it's very interesting because it shows what is happening with homeowners, pest control companies, lawyers, and foam. So let me go ahead.
Spray foam, it's been around for decades. You've probably used it to patch holes under the sink or to seal gaps in your home, but it's taking on a much bigger role these days. Contractors and homeowners are using it as home insulation. But the Fox 5 I-Team's Dana Fowl tells us some homeowners say it can hide a problem that is destroying homes. Good morning, Dana. This is a big, big problem.
Yeah, and this is spray foam. If you're not familiar with it, again, you may have sprayed it around something to keep a mouse out or something, but this is what is going inside of homes, and more homeowners today are using it. Spray foam insulation in their attics, in their basements. New construction goes so far as to use it in the walls, in the interior of the home. And that energy efficiency really is a selling point. It's a money saver, unless something goes wrong. How wrong? Some homeowners are losing the fight with termites and losing their pest control contracts.
It's clearly an infestation.
I opened the door and there's thousands of termites actually swarming. It was like a scene from The Birds.
Both homes had termite bonds, yet they became infested with termites. Formosan termites, known for their voracious wood-eating appetite.
We've lost hundreds of thousands of dollars, literally.
These coastal homes are insulated with spray foam. It's in the attic, it's in the crawl spaces, and it's been going on for a while there. Back here in Metro Atlanta, pest control operators tell the Fox 5 I-Team that spray foam used as insulation has exploded in recent years. In this suburban home, the spray foam is in the interior walls, and so are termites. According to the pest control operator who provided the Fox 5 I-Team with this video, the spray foam in this 2-year-old house is now home to termite tunnels going up 15 feet.
It's going to be a long one, but we should be done here.
All did it to lower their heating and air costs. Now, no one is suggesting that spray foam caused their termite infestation, but the attorney representing the coastal family says when termites get in, the spray foam, it's like a superhighway in your walls. According to the tiny house lawsuit, termites forage through it randomly and cause more damage than they otherwise would. Rick Bell from the Georgia Pest Control Association.
These are termite tunnels.
Says it sure makes them harder to detect.
It's like drawing a curtain over the wall that we need to look at.
Georgia's Agriculture Department just released a warning. Spray foam could hide termite damage and or the presence of live termites. Even in the best of conditions, termites can be tricky to find. Spotting termite damage can be tough sometimes. Let's take a look at this piece of wood. This is what you would find behind the drywall. It's helping to support your home. Seems solid enough, right? Well, this is what you don't see, what's happening on the inside. Attorney Tom Campbell shows us what's left of this Orange Beach, Alabama tiny house. It was a retirement dream for Leslie Eccles and his wife. The water is right there. Their RV was parked and ready to roll at any time. But while the Eccles were setting up house, the termites were building homes in their walls.
They can travel unseen. They don't eat the foam, but they mine through it. They'll go to the wood and the structure and go all over the house very quickly. And that's what's happened here.
According to the Eccles lawsuit against the pest control company for deficient prevention services, the house, it says, is a total loss.
Our place was absolutely destroyed from top to bottom, front to back.
It's catastrophic to the homeowners, and homeowners insurance doesn't cover termite damage.
But the pest control company, in a response to the lawsuit, contend they did provide professional advice and service on the prevention and elimination of termites. And they assert that there are no severe construction defects to this home. Down the coast in Pensacola, from Skyfox Drone, this is a stunning piece of waterfront property. But look more closely. Spray foam.
It covers the ceiling.
It's all over Ron Fleming's home. When he first saw termites, he said his pest control company got to work trying to kill them.
Well, the next year we got termites coming through the bathroom wall, eating up the back of the house.
Right here are a few dead in the windowsill. He can't get rid of them. He's waiting for arbitration with his pest control company to fix this damage.
It's our home, and we can't do anything with it. I'm 73. We want to downsize.
After facing mounting lawsuits, the pest control industry is pushing back. It has put out a consumer alert that says property enhancements, like applying spray foam insulation, can actually void your termite coverage. The Spray Foam Coalition writes that their foam does not attract or provide a food source for termites. It recommends more intense inspection techniques like moisture meters, infrared cameras, even specially trained dogs to sniff out termites.
This is what the place originally looked like.
Leslie Eccles' coastal dream is now in his rearview mirror. He's gone back to work to pay for a retirement he can't enjoy and a house he can't live in.
Again, look forward to the day that this nightmare can end for us.
Now, naturally, you can find termites anywhere in the country, but the Southeast is particularly vulnerable to these voracious Formosan termites. They eat a lot and they do it quickly, and we have a climate they enjoy.
Yeah, I'm pretty sure there are going to be a lot of people who are going to check and see what kind of insulation they
Absolutely.
have, you know. But if you have a termite bond, aren't you already covered?
Not necessarily. If you currently have a termite bond and you want to add spray foam insulation, you truly must reach out to that bond provider. This addition to a home could terminate that contract. If it's applied properly, it may not. But you have to check first. This is just the beginning of a series of stories we're going to be doing on this. We're going to be talking about, in the coming weeks, some water damage issues. We're going to be talking about a major heating and air company.
Spray foam.
Okay, so you can see it is becoming a real problem, and I know it is a problem for me just to do the inspections because with all the tools that I have, I just feel like I'm lost trying to find termites in these structures that have either EIFS or the spray foam insulation. And then, of course, for the homeowners, I've had homeowners that, they were just crying, and I was doing an inspection. They're crying, what am I going to do with this house? How are we going to get rid of the termites? So it's really a mess. But in any case, I want to show you a couple of case studies. So this is a restaurant, Ruth Chris Steakhouse here in New Orleans. And I got called in to try to find out what was going on. And, of course, the building, and you notice how pretty it is on the outside, though. But what you don't know is that it's all basically, fake. it's all EIFS on the outside. And the termites got in there. You can't detect them with an infrared camera. You can't even detect them with a moisture meter. This stuff is so good at preventing anything from going back and forth. And they cut some of that EIFS and they found carton nest, and the termite just chewed right through all that foam. It's perfect environment for them. They don't actually consume it per se, like the guy in the video said. They just mine through it. They chew it to get to the other side. But look what's behind all that foam. It's just brick. It was an old brick building. They put EIFS over it to make it pretty. Problem is, if moisture gets in there, there's no way for it to escape. Once you get moisture inside EIFS, it stays in there. So what they did find out is they had on the backside of the restaurant, they added on, and this was a flat roof. And on that flat roof, they had, obviously a bad installation. And then in other places, they had these nicks on the protective exterior. You can see it here on the right. And so the protective material, which is synthetic, somebody must have hit it and cracked it, and the moisture was getting in there. Once it like I said, once it get in there, you can't get it out. So in reality, this building should have had inspection once a year where they find these cracks. They use the special glue to repair it, and that way the moisture can't get anymore. But unfortunately, the moisture, it stays there. It's not going to get out. Case study number 2 is a very expensive home in Lakeview here in New Orleans also. I showed you this picture where Timmy up in the attic, just enjoying ourselves because it was so comfortable up there with the air conditioning. But we did find termites in that attic, in the rafters. But what they really wanted to know is that here on the right, this is the kitchen. That's the pantry. So the pantries are cabinets that were put on the wall. They were screwed to the wall, and they had swarms, Formosan swarms. So what they did is they put tape wherever the swarms were coming out, and that prevented the swarms from getting into the kitchen. But they wanted to know, can you tell us if there's termites or damage or moisture in there? Do we need to take the pantry, all those cabinets off, and get it treated? So we went to town with our infrared camera. In this particular case, we were able to see what was going on through the foam, because you don't see in between the studs. You see the studs, and you can see right above the pantry cabinets over here on the right, this big dark area. It's not missing foam because it's not square. Basically, it's either termites or it's moisture. So our advice after we finish inspection and wrote a report says you need to take those pantry cabinets down and break into the sheetrock and see what's in there. And this is what they found out. So they had formed a huge carton nest in the foam itself. They had eaten the studs. They had started eating the back of the cabinets also. And eventually, they put the termites under control. They treated them again. But it's again, this is what happens when you allow the termites to get out of control. This probably had been going on for a while. So what we also find out is on the driveway, they had EIFS. Well, they had EIFS all the way around, but in the drive, on the driver's side, they had cut the EIFS to see what happened, and they had trails all over coming in through there. And I don't know if you can see it right on the corner, a little bit above the corner on the right side, there's a hole. That was a treatment hole. So they did treat this whole area, and the termites still managed to get in. So all I can think is somehow or another, whatever was in there in that soil didn't allow the treatment to get next to the wall, and they were able to get in there. So it happens. Case study number 3. This was a mansion, a big, ginormous house with a big pool in Biloxi Bay. EIFS on the outside and spray foam, combination of spray foam and batt insulation. But they had I guess the homeowners had lost the property and the bank had purchased it, and then I guess they sold it, and this guys bought it, and then they started seeing problems. So they called us up to find out what had happened. By that time, they had removed a lot of the EIFS, and they already cut big holes in the walls and everything. So what I didn't realize is when we got there, it was early in the spring. It was like 40 degrees outside, and it was 40 degrees inside because they didn't have the heater on. So we got there and we couldn't see anything. Everything was gray. There was no contrast between the outside and the inside. And then we had to come back the next week. You can see how they just tore up all the sheetrock in the main entrance. And like I said, they had combination EIFS and on the outside and bad insulation, fiberglass insulation inside. And we were able to use the camera inside. They had put the heater on. It's only 61 degrees in there, but you can see the moisture in the walls and damage around the studs on the right side. And then they had a lot of other issues with construction. They had put EIFS all the way to the ground, and then they had a wall that was actually a fence that went into the wall and had EIFS all the way around it. So they basically just made the architect or whoever designed this thing, they made all kinds of mistakes in construction. You can see out there the headers on the bottom right above this is the exit from the kitchen into the pool, and they had eaten these huge headers. I mean, that's a lot of wood that put up that had, and there was a lot of moisture intrusion in there, so they had a lot of issues with they had to remedy. And my last case study here is this was just recently. We just did this spring. So this gentleman called us and said, I'm in the process of buying a house. We know we had termites. What we don't know is whether there's other areas in the house that have termites or whether we still have live termites. So would we do an inspection on this home? And when I asked him what kind of construction it was two-story brick. Yeah, it's brick on the sides, but it's EIFS in the middle. You failed to tell me that. And they also had spray foam insulation up in the attic. This was just a weird thing because they had put spray foam insulation on this construction area on that where the workers are. You can see they pulled a bunch of the shingles, and because underneath it, I'll show you the pictures, that's where they had the damage. They also had this little air intake, and they didn't know, but that had a leak in there, and they had a leak on the corner too. And they had trails. I remember what I told you about having too much vegetation too close to the structure. Well, these are hollies on the bottom, and they were really tight against the structure, so they had to come in and trim them in order to do inspection. I got in there on my belly and find out where there must have been about 5 or 6 trails, big trails, but they had already been treated with a liquid termiticide. Didn't find anything on the left side. There were trails right by the door, going right underneath the EIFS and into the corner of the house. So we did the inspection, but let me show you what happens when you have a leak and it's covered with spray foam insulation. So this leak must have been going on for a while. And what I don't understand is why they have bad insulation, which is fiberglass, over here on the right, and everything on the left was spray foam insulation. But then the rest of the house was all bad insulation. The only thing I can think of is they must at some point in time found this leak and they just figure we'll just put spray foam in there and they'll take care of the leak. Well, that didn't really work because termites really went to town on this side of the roof. And then of course they had to remove all the spray foam insulation, and that is a mess. They had blown in insulation in between the joists, and now you got all this mess on top of it. So somebody's going to have to vacuum all that. So we did the full house inspection. I went up in every attic. It is a monster house. And the guy, the gentleman that after I gave him the report, he decided to go ahead with the sale because, I told him basically that the termites have been put under control with the liquid termiticide. But I told him one of the problems that he had in here was 2 leaks. That they removed that little entry air gable, and there was a big leak on the left side of that thing. And of course, termites found they had damage all over in there. But they also had damage where the termites had gotten in. So they went in, and again, this is a mystery how they know that this is where they need to go in and then go up to find the moisture. So what I understand is that termites have scouts. So once they get in a home or in a structure, they send termites on their own and put little termite, they make pheromone trails. They don't put mud. It's like honeybees looking for flowers. Once they find the flowers, they put a trail back. So the termites put a trail back once they find moisture. And that's what happened. They went all the way up to the roof line, took off from this angle to your left, and then went up the rafters and find the moisture coming from the shingles and from the air vent. It's pretty impressive that they can do that. But I'll also find live termites during my inspection underneath this window. Underneath this window, so they didn't remove the batting, they just left it in place and they treated it. But there was a whole bunch of termites in a cart nest under this window, which after I removed all that batting, I found them in there, brought it outside and showed the homeowner, said, well, you still got live termites in there, whether they're going to survive or not, I don't know. But he wanted to know, are there any more termites, pockets of termites, and I couldn't find any other moisture in there. But that's the problem when you do these inspections. You can't be 100% sure. It's very, very difficult, and you have to be careful to say your house is absolutely free of termites, because that is never, unless you burn it down or fumigate it, and even after you fumigate it, they come back the next day. It's very difficult to make a statement like that without putting yourself into a lot of litigation. So I told them, this is what we found. You need to cut some more sheetrock to make sure there are no pockets of live termites, because there may still be some moisture up there, even though we can't see it with the infrared camera. So he did follow my recommendations, and he did write me a nice letter saying thank you for all the. And I haven't heard from him, so he went. I assume he went through the sale and is happy with what's going on. So just to give you a little summary then about what this EIFS and spray foam insulation. So they're great for reducing cooling and heating costs. The problem is that there are no application guidelines for from the spray foam industry that allow termite inspections. And these are causing headaches and nightmares for the homeowners and pest management companies. We already saw that video where, well, the 2 videos where NPMA says there is a problem and we need to talk to the spray foam association and try to come up with something that can help both, because what's going to happen is, one, homeowners are not going to be able to get their brand new spanking super efficient house under contract, because a lot of pest control companies say, I'm not going to take a chance and have termites show up in the foam. Then we have to rip all the foam and pay for all the damage. And homeowners may decide that if it's got foam, may not be able to get the proper treatment from a reputable pest control company. So it affects both. So the pest control company is going to lose a lot of contracts, and maybe the foam insulation companies are going to lose business, because then people are going to be afraid of getting the house foamed, right? So we got to come up with a solution for both industries, both for the application of foam and for the termite control people. So one thing that happened in Georgia, and I worked with Dr. Brian Forschler, entomology at the University of Georgia in Athens, is that he did a test where at the university campus, he found that they had native subterranean termites. So he called on a bunch of researchers in pest control companies and other individuals that do termite work, and told them, okay, we're going to find where the termites are in this building, in this basement, and we're going to label everything. And you're going to be using your instruments, you're going to be using the way you do it, and you're going to be using the way you do it. So we had almost every instrument we can think of, and people that just do it because they're good at it. And so we found all the evidence of termites, and where we could see termites, and found them. And then he had a company, a spray foam company, that did the spraying. They volunteered their time and their material, and wherever we had activity, they sprayed it with open cell foam and closed cell foam. Then after that, we went back and used all our instruments, or lack of instruments, and tried to find termites again. And all of us failed except one instrument, which is the Termite, because it uses basically microwave and detects movement, and he could detect the movement even deep through the at least if the foam wasn't any thicker than 2 inches, he could do it. So he presented this to the state of Georgia, and basically what happened is that Georgia came out with a compromise, which says that, well, it's going to be more work for PMPs, but they can remove or replace the insulation between each floor joist, so they can conduct a visual inspection of the foundation sill interface where subterranean termites can be evidence of presence. This is a direct quote from the paper. So Brian Forstler at least did some work on this to show that there is a problem with the foam, and we need to maybe come up with regulations for the foam industry so they can leave some areas without foam so we can do our inspections. So I gave a talk at the New Orleans Pest Control Association, and I gave a talk to the Baton Rouge Control Association, the same talk, and try to put a bug in the ear saying, you guys need to start thinking about this, and we need to bring it up to our regulators and see what needs to be done to save the industry, both the foam industry and the termite control. Because if all the new buildings are going to have foam insulation and EIFS, who's going to take care of the termites, right? So with that, I'm going to open it up for questions.
Okay, the first question is, can you spray the spray foam after it's installed with borates to prevent termites from foraging into that area?
I believe you can, but the borates, it's very good for dry woods, because the dry wood alates, the king and the queen, have to penetrate the surface of the wood to start their nest. But the borates only penetrate very little into the surface, and maybe a quarter of an inch at the most, depends on the kind of wood. But for most termites, they'll sacrifice a lot of workers to get inside the wood. And remember that lady in the video, how it showed it was hollow on the inside? That's what's going to happen. They're just going to come in from the inside. So you can do it. How successful it's going to be, that's debatable.
Okay, the next question is similar. During installation, why can't the foam have termiticide added to it?
That's a question for EPA, because anytime you put something inside the structure, it has to be, they have to study to make sure that's not going to cause health problems. So borates, on the other hand, is an inert mineral. It acts as an insecticide when they eat it, but putting an active ingredient that should go in the soil, it may create more problems than what it solves. And again, I can't say whether they can't or can't do it. I brought that question myself. Why can't they add something to the foam that makes it when the termites, make their tunnels through it, it'll kill them. So yeah, it's a good question, but I don't have the right answer for that.
The next question is, what is the wood moisture content that invites termites?
It's usually anything about 15%. Most of the what I've found in most buildings that are air conditioned, it's anywhere from 5 to 10%. The wood itself is going to have a moisture, even if it's not air conditioned or anything, it's going to have about 5 to 10%. But if you have a leak, it starts going above 10%, so 15, 20%. That's a lot of moisture. You start growing fungal. You start getting fungal growth in there too at that high.
Okay, that's the last question I see in the chat box.
All right. Well, thank you.
All right, thank you, Ed, for the presentation. Thank you, everyone, for attending. Everyone have a good day.
Bye-bye.